Good morning, Chem 20s. Our lesson today is a continuation of yesterday. Today we're going to continue with concentration, looking at the third type called molar concentration. Reminder that concentration is defined as the ratio of the quantity of solute to the quantity of solution or solvent, and we're using a variety of units. Yesterday, when we were looking at units, when we did percent by volume, our unit for concentration was percent. Yesterday as well, when we did parts per million, our unit was ppm. Today, when we're looking at molar concentration, our units are going to be moles per liter. Just review again from yesterday. We're using percent by volume when we're dissolving a liquid in a liquid, like in possibly alcohol concentration. We're looking in parts per million in very small, very tiny, minute ideas like how much asbestos or how much mercury is dissolved in something. And then we're going to look at today the one that we use most often, the one that scientists or we would use in the lab, which would be moles per volume. Now, if we take a look at molar concentration, the formula sets up very similarly to other formulas we have done this year. Again, C will stand for, in this formula, concentration of our solution in moles per liter. N is still the chemical amount of solute in moles, and V will once again be the volume of the solution in liters. When we say molar concentration, we are talking about the unit in moles per liter. So when a question says, please find molar concentration, you have to make sure the unit that you provide is in moles per liter. The second thing I want to point out is moles is again a quantity we can't calculate in the lab. Therefore, we are going to make a connection with something we've previously done, which is changing first mass into moles. And this, again, for some questions, might be a multi-step process. Well, let's do the very first question together. So, example number 1, a 52 milliliter solder flux container available in hardwares and craft stores contains 0.1174 moles of zinc chloride. What is the concentration of the zinc chloride in the flux? Now, this is one of those substances you would use if, let's say, you were going to do stained glass. That's what you use solder for, especially this sort of craft solder. So we're going to make a list of variables down the side. So we have a volume of 52 milliliters. And we already know that we want our answer we want moles per liter for concentration. So I would like to convert this to liters. So I'm going to go from milliliters up. So I'm going to divide by 1,000. We have our moles of 0.1174. And we are trying to find concentration. So we have our new memorized formula, C equals N over V. We're going to put 0.1174 moles on top, divided by 0.0520 liters on the bottom. And we're going to type it into our calculator. 0.1174 divided 0.052. I go back to the question, 3 sig figs, 4 sig figs. So I'm going to put it into 2.26 moles per liter. In this question, we would get 1 mark for the formula, 1 mark for substitution with units, and a 3rd mark for correct answer with units in the correct number of sig digs. So this question would be out of 3. What I would recommend doing is, why don't you try this question for yourself? Copy down the question, pause the video, make your list of variables, go through the question, and then unpause the video to check your work. So in this question, we have a container of acid has a concentration of 40.3 moles per liter. If the researcher poured 72.0 milliliters into a beaker of acid, what amount of acid would the researcher have? So first thing we got to do is change this to liters. We are trying to find amount. And reminder, chemical amount always means number of moles in chemistry. So we're going to start with our memorized formula. C equals N over V. I'm going to solve for N, so that means V is going to move up to the other side. N equals concentration times volume. So we're going to take 40.3 moles per liter. We're going to multiply that by 0.0720 liters. So 40.3 times 0.072. Again, I go back to the original questions, 3 sig figs, 3 sig figs. So I'm going to have 3 sig figs, 2.90 moles. We're going to give, again, 1 mark for the formulas. You need both. 1 mark for the multiplication, substitution with units, and 1 mark for the answer with units in 3 significant digits. Okay, last question. We've done questions similar to this before, just not using this formula. Again, let's make a list of variables, unpause the video, and check your answer. So we have a mass here of 30.0 grams. We know the moment we see a mass, we need to calculate molar mass. So let's look at what substance we have. Sodium chloride. So this is going to be NaCl. Again, I would recommend turning it from words into symbols so that you have some reference to look up molar mass. We're going to add together sodium and chloride, so that's 22.99 plus 35.45. And this guy is 58.44 grams per mole. Again, I do not need to see your work for this. We are trying to find the volume of salt. And if I look, it says we are also making a solution concentration of 1.74 moles per liter. So looking here, I have enough information. I can find moles. So moles equals mass over molar mass. My mass is 30 grams divided by 58.44 grams per mole. So 30 divided 58.44, enter. I have I need 3 sig digs, 0.513. Oh, sorry. Nope, 0.513 moles. Hit the wrong button there. We're going to find volume. So my formula is C equals N over V. I am solving for V. Remember, V is in the denominator. Therefore, I have to move it up to the other side, which means I have to move concentration down. So my formula is going to turn into volume equals moles over concentration. Take 0.513 moles on top, divide by a concentration of 1.74 moles per liter on the bottom, and we're going to put this back into our calculator. Again, I have the full number on my calculator, so I'm just going to hit divide by, and the answer is going to pop up, 1.74. We still have 3 sig digs, so my answer is going to be 0.295. Moles cancel. This is going to be in liters. Again, if you want to convert it to milliliters, you're welcome to. However, I would think that this answer is just fine in liters. So this question would be out of 6 formula, substitution with units, answer with units, 3 sig digs, formulas, because we had to manipulate it to move it around, substitution with units, answer again with units in 3 sig digs.